Okay, hello. Now we have an RL parallel circuit. In this case we have a resistor in parallel with an inductor in parallel with the power supply. So at this point the values that I have on here is 200 volts across the inductor, a 10 amps passing through the inductor, and 40 ohms of resistance at the resistor itself. We need to start filling in some of the blanks here. This is a parallel circuit. What did we learn about parallel circuits? Is that the voltage is equal across all branches of that circuit. So in this case, if this inductor has 200 volts across it, then so does the resistor have 200 volts. So we can fill in 200 volts. That means we know the power supply itself is a 200 volt power supply. We filled in a few of the blanks and maybe we can get some work done here. So let's get started. In the inductor case, I know I have 200 volts and 10 amps, so therefore I can figure out what the inductive reactance is, and that would be XL. What is the inductive reactance? If I lay this out here, XL is equal to EL divided by IL, and in this case it was 200 volts divided by 10 ohms, and if I get my calculator out, 200 divided by 10 equals 20. So we know we have 20 ohms of resistance across this inductor. The inductor has 20 ohms of resistance. And with that information, we can also figure out what VARS L is. So we can figure out what VARS L is using I and E. VARS L is equal to EL times IL. In this case, again, EL is 200 times 10. So my VARS L is equal to, that's 10 amps, 200 times 10, which is 2,000 VARs. Volts, amps, reactive. That's what VARs are. So I've got 2,000. If I want to figure out my inductor, how much inductance there is on that inductor, then the formula for L is XL divided by 2 pi F. And again, F is 60 hertz, so 2 pi F is 377. 2 times pi times 60 hertz, and if I don't tell you that it's something different than 60, then it must be 60. And my XL in this case was 20 ohms. So 20 divided by 377 equals 0.053 Henry. 0.053 Henry. That's the inductance value of this inductor. Moving on to our resistor, I have the E and the R. I can figure out what the I is. So with voltage and resistance, I can figure out the current. So if I'm looking for IR, all I need is ER divided by R. So ER, we knew, was 200 volts across the resistor, and the resistor value itself was 40. I think it is 40. 200 divided by 40, IR is equal to 5 amps. We put that right here, 5 amps. And with the amperage and the voltage, I can figure out what the power is. What is the true power? I know the I and the E, so I can figure out what the P is. True power is P is equal to IR times ER. And you can't see that, I don't think. So let me move that. There you go. And so the IR is 5 and the ER is 200. We knew there was 200 volts across the resistor, and we just calculated the 5 amps. So 5 times 200, the P in this case is equal to 1,000 watts. 1,000 watts. Perfect. Now when we start looking over here at the power supply, we've got all this filled in. We know our voltage. We could calculate the current. And the current would be IT. In this case, it could be figured out to be IT is equal to IR squared plus IL squared. And IR squared is 5 squared plus IL. Yeah, IL is 5. IL is somewhere on here, is 10 squared. And what's the square root of that? So let's figure it out. 5 squared plus 10 squared equals, and then the square root of that is 11.18. So IT is equal to 11.18 amps. So I can put that in here, 11.18 amps. Now an easy way to figure out Z would be to take the E, the voltage, and divide it by the current. E divided by I would give me Z. But we can also figure out what Z is using a different formula, using 20 and 40. So we can figure it out either way. But let's do Z is equal to the square root of R. Oops, I got that wrong. We got the wrong formula. Give me a minute. I started writing down the wrong formula. I don't want to do that. Z is equal to R times XL divided by the square root of R squared plus XL squared. That's one of the formulas we can use. And in this case, we start plugging in the numbers. R was 40 times XL was 20, and we're going to divide that by 40 squared plus 20 squared. So at that point, 40 times 20 is 800 divided by 40 squared. Let's do that. Divided by 40 squared plus 20 squared equals, and then what the square root of that is, and that is 44.72. So in the end, Z will equal 800 divided by 44.72. 800 divided by 44.72 equals 17.89 ohms. So Z is equal to 17.89 ohms. We're looking for the VA. If we want to figure out the VA, one of the easy ways to do it is using E and I. The voltage times the current will give us the VA. There are other formulas you can use, but voltage ET times IT in this case will give me the VA. The ET we knew as 200, and the IT we knew as 17 point, whoops, I got the wrong one. The IT we knew as 11.18. Let me correct that. 11.18 amps. So I get my calculator out. 200 divided by 11.18 equals, wait a minute, I've done something wrong. Because I divided, I didn't multiply. So 200 times 11.18 equals 2,000, so the VA is equal to 2,236 volt amps. Alright, so let's write that in here. 2,236 volt amps. Now if I want to figure out the power factor, I can use the VA and the P. To do that, power factor is equal to P divided by VA. 1,000 divided by 2,236 VA. We get out the calculator. 1,000 divided by 2,236 equals 44.447 as our power factor. And to figure out angle theta, we just hit second cosine Something went wrong there. I'm going to try it again. 0.447 second cosine gives me an angle of 63.45 degrees. And now I can write those two back in here. 0.447 is my power factor, and my angle is 63.45. Remember, the angle can never be greater than 90, and the power factor can never be greater than 1. We can't have that. Gentlemen, I think that's it. We finished the RL parallel circuit. Thank you very much.